Hi guys, we're doing the 10A Part 2 notes, and this is example number 8. Again, we're asked to find the sine of theta and the cosine of theta, given the tan of theta equals 5/12. And just like we have before, we're going to go ahead and remind ourselves what our trig identities are. This SOHCAHTOA thing is the best thing that you can do when you're beginning a problem with trig. Just write it down every single time. Okay, memorize this so that when you're working on a trig problem, that's your go-to. Then you're going to ask yourself, well, what is it that I'm trying to find? Well, I'm trying to find the sine of theta. That's a ratio, and I'm also trying to find the cosine of theta. And that's, again, another ratio, right? We have these ratios here for us in SOHCAHTOA. Okay, so the next thing that we need to do, of course, is to draw this triangle, because we weren't given a triangle in this problem, right? Sometimes you will need to draw your own picture. When we do draw that picture, what we're realizing is that we are given the tan of theta. And of course, the tan of theta, what we're given is 5/12, and we know that that's the opposite side over the adjacent side. So we know that there's the measurement for our opposite side, there's the measurement for our adjacent side. And when we go ahead and do our triangle, we're going to write our triangle, draw our triangle. We want to, of course, be sure that it's a right triangle. All triangles in trig are right triangles. And we learned that when we did our trig introduction. So if you need to go back and review that, do that. When we draw our right triangle, we want to always be sure to draw our little right angle indicator, indicating that, yes, indeed, that is a right triangle. And then, of course, the next thing that we want to do is we want to draw a theta. Now, does it matter which place you draw it? No. You could just as easily draw this theta on the opposite side. Of course, this side is always our right angle, okay? But this theta could just as well have gone here. In fact, let's just go ahead and do that on this problem so that you guys can see that. So we'll put our theta here. And then when we are assigning all of our sides, which is the next thing that we want to do, we want to use our right angle, of course, to identify our hypotenuse. And then we're going to use what we're given with the given that tan theta is 5/12. That's telling us that the opposite side is 5. And of course, the opposite side is that side all the way across from the angle theta. And we're told it's 5 long, right? Now, the adjacent side is the side that is right next to theta, and it's 12 long. We don't know how long the hypotenuse is, and so we will need to be using the Pythagorean theorem formula. A squared plus B squared equals C squared. Of course, that is leg squared plus leg squared equals hypotenuse squared. That's another way to think about that. Our legs, of course, are these two sides that make up our right angle. So we have 12 squared plus 5 squared equals that unknown side, or that x squared on the hypotenuse side. And in order to solve this, just like we did on our other examples, we're going to multiply that 12 times 12, which is 12 squared, and the 5 squared, and we'll get 25. So we'll have 144 plus 25 equals, still got that x squared. We'll add these together to get 169. And then in order to get x, which is what we need to know the length of the side, we don't want that x squared. we want to take the square root of both sides. And we're just going to swap these around, and that'll give us x equals 13. And when you find the square root of that 169, again, don't hesitate to go to your calculator, hit your square root function. If it ends up with a whole number, by all means, use that perfect square root. So that side length that we're missing, we'll go ahead and fill in now. Instead of having x for that hypotenuse, we'll just go ahead and we'll fill it in with what we found out using that formula, that it's 13 long. All right, so going back to what we're actually being asked for, the sine and the cosine of theta, we're going to use that SOHCAHTOA to remember that the sine of theta is the opposite side over the hypotenuse, opposite side being 5, hypotenuse being 13. For the cosine of theta, it's adjacent over hypotenuse, so 12 over 13. All right, and that's how we work problems like this. All right, thanks for watching, guys.